Okay, in this video I'd like to revisit how we programmed our TI Nspires to execute the quadratic formula for us, and also remind you that this technique can be used to program any formula into this calculator. So I've already gone to my home screen and created a new document, and we're just going to be working out of a calculator document here. And what I mentioned in class is that we need to call the command define, and from here we can provide a name to the formula that we would like to execute. I'm going to call this one QFP for quadratic formula plus. And any quadratic formula requires the use of A, B, and C as parameters or values. So we're defining this QFP program with A, B, C as the parameters, and we're going to say that that's equal to the quadratic formula. And we have to define that here. So I'm going to press Control and divide to create this empty fraction, and now I can type the quadratic formula. The opposite are B, plus, now we can't do both of those at the same time, that's why we're going to call this one QFP, quadratic formula plus. We're going to enter a square root here and type B squared minus 4 times A times C. It's important that you put your multiplication signs here, otherwise the AC will be treated like its own parameter, and we're not providing AC as a parameter. We're providing A and C separately. So now we'll move down to the denominator here and type 2 times A. Now that looks like the quadratic formula, the plus component of it, so I'll just tap enter and the program or this formula has been saved. If we tap the up arrow twice to highlight our formula from the line above, we can tap enter and bring it back down and continue editing. So I'm changing this plus sign to a minus, and I'm changing the name to QFM for quadratic formula minus. And press enter again. Now we've got that saved. And as you've noticed, with a little bit of practice, entering these commands goes very quickly if you're using the calculator software that's built into our computers. However, if you have to use the handheld as well, you can type all of that using the keypad at the bottom of the handheld. It's just a little bit slower since the buttons are smaller, and I personally have trouble when the keyboard is in this alphabetical order. Now off screen I just created a quadratic equation, x squared minus 6x plus 8, and we have two solutions that exist on the x-axis. If we didn't have access to this graph, or if we didn't want to go through the trouble of graphing, we could find these two solutions by using the quadratic formula we just programmed. So if I type QFP with the coefficients 1, -6 and 8, these are the coefficients that match the quadratic function that we're dealing with. Tap enter, there's one of my solutions. Now if I call QFM with 1, -6 and 8, then I should get the other. And if we double check our graph over here, certainly we do see an x-intercept at 2 and again at 4. So I'm fairly confident in that our computation worked just fine. Now it's important to note that if you're going to use this quadratic formula in future instances, maybe later in class, that you'll need to save your work here. So if we choose File, whoops, cancel that, we'll choose File and select Save or Save As. We can provide a name to it and save it to this document, or I should say save it to the program. Now if I go to the home page and choose Browse, I can scroll down and find the file that I just saved. In this case it's quadratic formula, and it comes back right where we had saved it. So I have two examples here, the definitions in place, and in this case a picture of one of our graphs as an example. Now that this definition has been saved, we don't need to type it ever again within this document. So anytime that I need to use the quadratic formula with any numbers, let's say a variable of, or a value of 1.5 and a b value of 2.5 and a c value of 10, this might get kind of interesting. Well, we've got a result that's been produced by this calculator. Some long decimals are included, as well as an imaginary component to this complex number. So yes, even though we get no real solutions to this particular example, we do have solutions that are presented by the calculator. Now it's our job to interpret them. But I'll save that for another discussion. If you have questions on this, please let me know. Otherwise, I'll see you in class. Thanks for watching.